You're looking live at the Northrop Grumman facility in Promontory, Utah, where in about 20 minutes, you're going to see a lot of smoke and fire as we test the solid rocket booster for NASA's Space Launch System rocket. Good afternoon, everyone, and welcome. I am Shannon Segovia at NASA's Marshall Space Flight Center in Huntsville, Alabama, home of the Space Launch System program. We're counting down to our 2-minute booster test that will happen at 1:05 Mountain, 3:05 Eastern. Be sure and follow us on social media. We will be taking your questions throughout the show on our social channels. You can use the hashtag AskNASA. Also, if you are watching on Facebook, be sure and put your questions in the comments, and we will be taking those there too. NASA is building the Space Launch System rocket, or SLS, to send the Orion spacecraft on our Artemis missions to the moon. To launch missions to the moon, you need a lot of power and you need a lot of energy. And these twin solid rocket boosters that you see on this model provide 75% of the power needed to launch SLS to space. For the Artemis I mission, SLS will launch an uncrewed Orion spacecraft next year from the Kennedy Space Center in Cape Canaveral, Florida. And this mission will really provide the foundation for NASA's deep space exploration missions. Now we are looking live at a view of the Northrop Grumman Promontory facility in Utah, where our booster will be tested today. And as you can see, the booster is anchored in the stand horizontally since it's not being launched. And today's test is called the Flight Support Booster Test 1, or FSB-1. And it is a ground test conducted with one booster. It's the first test that will examine materials and processes that may be needed to improve the booster on future Artemis missions. And the booster being tested today will fire for a little over 2 minutes and produce around 3.6 million pounds of thrust, just like the booster will do during launch. We are bringing you coverage today of the first Space Launch System Flight Support Booster Test at the Northrop Grumman facility in Utah. And we hope you all stay with us today because this test is going to be really, really cool. And we're about 17 minutes away from it. And while we wait, we are going to hear from a Northrop Grumman engineer who will tell us all about it and what we can expect to see today.
Hi, my name is Nicholas Chaston, and I'm the ballistics engineer in charge of predicting motor performance for the Flight Support Booster 1, FSB-1. Here at the Northrop Grumman's Promontory, Utah facility, we manufacture the solid rocket boosters for NASA's Space Launch System that will launch Artemis missions to the moon and beyond. Today we are testing one of those boosters in our Promontory test area. The SLS booster motor measures 167 feet long and 12 feet in diameter. We have successfully completed 5 previous tests to qualify for flight. This test, dubbed Flight Support Booster 1, or FSB-1, will evaluate new propellant materials and verify that all ballistic requirements of the motor are met. Preparations for this test began in March. The first of 5 segments was installed in the test bay in April, and the last one completed installation in June. The motor has been cold conditioning to a target temperature of 60 degrees Fahrenheit to 70 degrees Fahrenheit over the last several weeks. All of our large solid rocket motors undergo ground tests at our Promontory site before ever flying. In addition to holding this 1.6 million pound motor in place, the structure houses all necessary electronics and instruments needed for motor firing and gathering performance measurements. Ground tests such as these give us the opportunity to collect additional data parameters on the performance of the motor that would not be possible on a flight. Upon ignition, the motor at this target temperature will fire for about 122 seconds and produce 3.6 million pounds of thrust. The 5-segment SLS rocket booster is the largest solid rocket motor in the world.
You're looking live at the booster in the test stand in Promontory, Utah. In about 15 minutes, you will see just how powerful this booster is. I've actually seen one of these booster firings in person, and I can tell you it is an awesome experience to feel your legs shake and to see this piece of hardware come to life that engineers and technicians have worked so hard on. The Space Launch System rocket is the most powerful rocket ever built, and it will send the Orion spacecraft to the moon for the Artemis missions. Even during this pandemic, NASA and our partners have worked very hard to protect and keep our employees and team members safe, all the while building hardware and conducting tests like the one you are about to see today. Now we're going to hear more about that from NASA Administrator Jim Bridenstine.
Even in the midst of a pandemic, it is important to note that the United States of America can still do stunning achievements. We saw that recently when we launched Perseverance to Mars. We saw it when we launched Bob and Doug on a SpaceX Falcon 9 rocket in a crew capsule called Dragon to the International Space Station, and we brought them home safely. We can do these things, and we can do them safely, even in challenging times. And now we're building the most powerful rocket in the history of humanity that will take not just the next man, but the first woman to the moon by 2024 in the Artemis program. This program is commercial in nature, but it's also international in nature. And so we're very grateful for our partners that are building the FSB boosters so that we can ultimately achieve the objectives of our nation and, in fact, lead the world.
If you are just joining us, I am Shannon Segovia in NASA Communications. We are here today for the Flight Support Booster Test 1, or FSB-1, for the Space Launch System rocket from Promontory, Utah at the Northrop Grumman facility. We've been talking today about the SLS and about these rocket boosters that you see here on this model, and these boosters will help launch SLS to deep space. Now, we're going to see a video that's going to give us a little more information about NASA's Artemis missions and our journey to the moon. Only a few people in the world know what it's like to ride a rocket into space, and we are very fortunate to get to hear from one of those now. NASA astronaut Randy Bresnik recently sat down to share his thoughts with us about being an astronaut, space exploration, and today's test.
I got the opportunity to fly in some 4-segment boosters on STS-129, and now we're putting out our 5-segment booster test. That's going to go on SLS, which is, the world's largest, most powerful rocket when we launch this thing off. And that's going to be the first time that SLS and Orion fly together. Maybe uncrewed, but it's going to prove out the ability to be able to put crew on Artemis II in 2023. And so that's why it's really exciting. I mean, with 20% more, propellant and thrust and power in it, we're going to be able to go that much farther. I mean, because these two boosters on the side of the SLS, that's like 75% of the thrust of the system. Well, it's always important to test like you fly, because eventually you got to put the humans on it. And if we've taken all the precautions and getting all the test points and set up the test properly with initial conditions, we're going to be able to prove out that when we put the people on it, it's going to be just like we've done in testing. And if we've done that, we've practiced it properly. Orion and SLS are the backbone of the whole Artemis and space exploration right now, because they are the part that starts the mission. Orion carries the crew all the way to lunar orbit, because SLS has lofted it and then sent it there. And then Orion brings the crew back safely to Earth and splashes them down in the ocean. We've got to have safety for the folks building the, whether it's the solid rocket motor boosters or the launch abort system solid fuels. The fact that, these fuels are not exactly just, as docile as water, especially in these trying times with the virus, that, everybody's able to continue working and amazing work these past several months. And so I appreciate everybody continuing to work safety, so that when we get to flight, we know that the folks riding the rocket have the safest ship available, and you've done everything you can to make it safe for us to return to our families at the end of the mission.
We're now only 7 minutes away from go time for the Space Launch System solid rocket booster test from the Northrop Grumman facility in Promontory, Utah. We're getting ready to go to Northrop Grumman, and we will stay there throughout the test. Now, to tell you a little bit about what you can expect, the test conductor, we're going to hear them shortly talking to the team about the test. Then around 1:05 Mountain, 3:05 Eastern, we will hear the conductor say fire, and that will start the test, and it will last a little over 2 minutes. Continue to send us your questions using the hashtag AskNASA, as we will be taking those on social media through the end of the show.
T-minus 6 minutes.
Central Support Systems Operator, this is the test conductor. Turn on the water boost pumps.
Water boost pumps are on. T-minus 5 minutes. T-97 test area is clear for static test. High-speed operators verify systems.
All high-speed systems are streaming.
Roger. T-minus 4 minutes.
This is the test conductor. Report system status.
Support systems are go for static test.
Low-speed systems are go. High-speed systems are go.
Motor temperatures are go.
We are go for FSB-1 static test.
T-minus 3 minutes. Low-speed data operators begin recording. High-speed data operators at T-minus 60 seconds begin recording. Report at that time.
All low-speed data systems are recording.
Roger. T-minus 2 minutes. T-minus 90 seconds. T-minus 80 seconds.
Test control coordinator, stand by to commit the motor.
Standing by. T-minus 70 seconds.
Commit the motor.
Motor is committed. T-minus 60 seconds.
All high-speed systems are recording.
Roger. T-minus 50 seconds. T-minus 40 seconds. T-minus 30 seconds. T-minus 20 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. T plus 5 seconds. T plus 10 seconds. T plus 20 seconds. T plus 30 seconds. T plus 40 seconds. T plus 50 seconds. seconds. T+70 seconds. Plus 60 seconds. T plus 70 seconds. Plus 120 seconds.
Activate head and CO2.
Activated.
Activate quench tool command forward and aft CO2.
Activated.
Plus 170 seconds. High-speed data operator, stop recording.
High-speed recording is complete.
Roger. Low-speed data operator, stop recording.
Low-speed data recording complete.
Roger. Post-fire crew, report to the instrument room. Post-fire crew, report to the instrument room. Plus 4 minutes. T plus 5 minutes.
Wow, how amazing was that? And to see all of that power packed into those boosters. From our view, it looks like everything went great, but our engineers and technicians will continue to analyze the data and use it to improve future boosters on future Artemis missions. This test is not only about power, but really it's about the technical innovations that will help us explore the moon and Mars for generations to come. Now, we're going to go hear from Northrop Grumman Vice President Charlie Precourt.
As a 4-time space shuttle astronaut, I know what it's like to fly the space shuttle rocket boosters. And the 5-segment boosters will add far greater lift capability than the shuttle had. When those rocket motors light, you know you're going somewhere. I'd love to ride on the SLS and can't wait to hear the experiences of the first SLS astronaut crew. As Vice President of Northrop Grumman Propulsion Systems and a former NASA astronaut, it's important to me to ensure we have what is necessary to establish a presence on the moon and then go on to Mars. Testing our rocket boosters is how we can help ensure astronauts can explore space safely. Thank you so much for joining us for today's test.
And that will just about wrap things up for us today. Thank you so much for joining us. If you missed the test or you would like to see it again, we will be replaying it here on NASA TV, so stick with us. Also, if you would like to watch it on our social media channels at any time, you can go there and watch it. To follow our progress, continue to monitor our social channels, especially Twitter at NASA and at NASA_SLS. And also for all the latest on Artemis, visit our nasa.gov/Artemis webpage. Thanks again, and we will see you next time.